going to study right now in details series circuits, parallel circuits, and combination of both of them series parallel. And I have a couple of examples that we are going to solve it here in the board, and after that you can practice in your home trying to solving series circuits and parallel circuits. Okay, we are going to start with a series circuit. Okay, this is a typical series circuit. We are going to refresh the picture. This is the battery. I have the positive terminal here, the fuse, the breaker on off or switch on off. After that, two loads. One load and the other one connected in series. Follow me. This is the positive. The positive enter in the bottom of the light bulb, and from the case of the light bulb, start and connected into the positive of the next one, and after that, from the negative, return into the negative of the battery. Okay? What happened in a series connection? What happened with the ohm load? What happened with the voltage? What happened with the intensity? And what happened with the resistance? Okay, let me check. The voltage in a series circuit increase. The total voltage will be the voltage number 1, the voltage in the load number 1, plus the voltage in the load number 3, plus the voltage in the load number 3 and 4 and 5. Yeah? The voltage increase. The total voltage will be the voltage number 1 plus voltage number 2 plus voltage number 3 and increase depending on the amount of loads that you have in the series circuit. What about the intensity? You remember when you connect two batteries in series, what is constant? The intensity. You remember when you connect two batteries in parallel, what is constant? The voltage. It's exactly the same. In this circuit, series circuit, what is constant? The intensity. The intensity, the total intensity will be equal to intensity number 1, intensity 2, intensity 3, equal to all the intensities. Oh, wonderful. What about the resistance? Okay, the resistance, because the loads are connected in series, the resistance increase. The total resistance will be resistor number 1 plus resistor number 2 plus resistor number 3. Alright? This is a typical series circuit. I prepared for yours this example. Suppose that we have a series circuit with 3 loads, 3 resistors. Resistor number 1, 5 ohms. Resistor number 2, 10 ohms. Resistor number 3, 15 ohms. And we are going to calculate all the values. We are going to calculate voltage, intensity, and resistance in each point, in point number 1, point number 2, point number 3. And we are going to calculate the 3 values, voltage, intensity, and resistance at the source of the power. Total voltage, total intensity, and total resistance. Okay, in this particular case, I know the total voltage and the total, resistor 1, resistor 2, and resistor 3. I need know one intensity, because the first step is identify what is constant. In this particular case, because it's series, the intensity is constant. I need know the intensity in one point, and immediately I know the rest of the intensities. Okay, what intensity will be easy to find it? Probably the total intensity. But the only way to calculate the total intensity is if I know the total resistance. But I can calculate the total resistance. How much is the total resistance in a series circuit? Is equal to resistor number 1 plus 2 plus 3. Okay, the total resistance is equal to resistor number 1 plus 2 plus 3. 5 plus 10 plus 15. Okay, the total resistance is 30 ohms. Okay. If I know that this is the next step. If I know that the total resistance is 30 ohms and I know the total voltage 20. Okay. The total intensity is 20 divided by 30 is 2/3. Is 2/3. And right now I know the rest of the intensity. 2/3, 2/3, and 2/3. Because those intensities are constant. Right now, it's easy solving the rest of the circuits, because in each point, I know the intensity and the resistance, intensity and resistance, intensity and resistance. With the ohm load, I can calculate voltage 1, voltage 2, and voltage 3. How much is the voltage 1? It's 2/3 times 5, 2/3 times 10, and 2/3 times 15. Okay. The voltage number 1 is 2/3 times 5. Is equal to 10 divided by 3. Voltage number 2 is 2/3 times 10 is 20 divided by 3. And voltage 3 is 30 divided by 3. Now I can calculate the total voltage. The total voltage will be 10 divided by 3 plus 20 divided by 3 plus 30 divided by 3 is 60 divided by 3. The total voltage is 20. Oh, yeah. 20 is equal to this plus this plus this. All right. Right now, I am going to fill the rest of the table. This is the voltage number 1, voltage number 2, voltage number 3, the total resistance, the total intensity. Right now, the circuit is solved. This is a series circuit, easily solved.